In this video, we're going to try to solve the following question. So let S be the sum of the reciprocals of the divisors of 6 to the power n. What's the limit of Sn as n goes to infinity? Okay, so here we have many terms that we need to pay attention to before we proceed. So Sn is the sum of the reciprocals of the divisors of 6 to the power n. Okay, so we're gonna start from here. What are the divisors of 6? First, without the n. So we have 1 divide 6, 2 divide 6, 3 divide 6, and 6 divide 6. Also, we have 2 to the power 2 if we assume that this works. So 2 divide 6 to the power 2. Okay? And 3 to the power 2 divides 6 to the power 2. And 6 to the power 2 divides 6 to the power 2. And 2 to the power 3 divides 6 to the power 3. Okay? 3 to the power 3 divides 6 to the power 3. And 6 to the power 3 divides 6 to the power 3. We can see that we have a bunch of divisors for 6 to the power n. We have 1, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, until 2 to the power n. And also we have 3 to the power 2, 3 to the power 3, and etc. until 3 to the power n. Okay? Because remember, we can write 6 as 2 times 3 to the power n, and we can write it as 2 to the power n times 3 to the power n. And we can see that 2 to the power n divide 6 to the power n. And also any other number less than this. Also 3 to the power n. 3 to the power n minus 1. 3 to the power n minus 2. We see that we have these numbers, 3 to the power 2, 3 to the power 3, until 3 to the power n. Also, we have 6 divides 6. 6 to the power 2 divides 6 to the power n, and etc. until we get to 6 to the power n. Okay? Now we need these reciprocals. Okay? Because Sn is the sum of the reciprocals of the divisors. So these are the divisors. So the first one is 1. So Sn is going to be something like this. 1 plus 1 over 1 is 1. So 2, we're going to divide 1 over 2. We're going to divide all this one to find the reciprocals. So 1 over 2 squared plus 1 over 2 to the power n plus 1 over 3 plus 1 over 3 squared until 1 over 3 to the power n. And finally, we're going to get 1 over 6 plus over 6 squared until 1 over 6 to the power n. Okay, now we see that we can, doing so, okay, we can find the limit. So the question is, what's the limit of Sn as n goes to infinity? Okay, so what we can do is, we have this sum that we need to get in one term or in one form, and after that we take the limit. Okay, or at least we need to simplify this, but there is an easy way. So this one here is a geometric sequence of common ratio 1/2. This one is a geometric sequence of a ratio of 1/3, and this one is a geometric sequence of ratio of 1 over 6. But there is one thing that's missing. Here we need to have 1, so we add and subtract 1. Minus 1 plus 1. Here we need to have 1 plus minus 1. Okay? To make it easier in the computation, there are many other ways. So now we know that for a sequence that's geometric, the sum is given by 1 minus a to the power n plus 1 minus 1 over a to the power 1. Here our a is going to be 1/2, here is going to be 1/3, and here is going to be 1/6. So therefore, we're going to have, so adding this 1 minus 1 minus 1 is going to give us minus 1. This term here, no, sorry. So it's minus 2 because we need this one here to be in this sum. Okay, so this first one is going to give us 1 minus 1 half to the power n plus 1 over 1 minus 1 half. This second one is going to give us 1 minus 1 over 3 to the power n plus 1 over 1 minus 1 3. And the last one is going to give us 1 minus 1 over 6 to the power n plus 1 over 1 minus 1 over 6. So here we can get some simplification. This is less than 1. And therefore, when we take the limit, so this is our Sn. So now we take the limit of Sn. So once we take the limit, this one is going to go to 0. This one is going to go to 0 because it's less than 1. So 1 over 3 is less than 1. 1 over 6 is less than 1. 1 over 2 is less than 1. So all this one, they're going to go to 0. So we're going to be left with this one. So this one is going to give us 1 over 1 half, which is 2. And this one is going to give us 1 over third, which is 3 over 2. And this one is going to give us 6 over 5, which is 6 over 5. Yes, which is 6 over 5. Okay. Now we get rid of this. All we are left with is 15 plus 8. Yes, it's 50. This is 2. It's 15 plus 8, which is 23 over 10. So as the limit goes to infinity, our sum S will be 23 over 10. Okay? So the key is to find in the divisors and get the reciprocals and see that we have a geometric series in each case. And that's how we get the sum of these divisors. Okay? Okay, if you see any mistakes or any errors, please comment and contact us. Thank you very much.